Hello, everybody. Welcome back again to this series of webinars, How You Can Build Great Solutions with a Microsoft Azure Well-Architected Framework. Today, we have already come to the third episode, in which we're going to have a deep dive into the operational excellence pillar in the framework. So who am I talking? My name is Jing Liu, and I'm a cloud solution architect working in a partner organization at Microsoft Sweden. Without further ado, let's kick off. All right, so as sort of already a tradition, I would like to start the session by asking you some of the typical questions in the operational excellence area. Maybe you have already got similar questions from your customers, or some of the questions are actually internal that you sometimes ask yourselves to reflect on this area. So for example, how operationally mature is your cloud environment? Are you incorporating modern practices today, such as DevOps, into the way your organizations operate? Are you able to assess the health of your infrastructure? Are you provisioning resources manually, or have you actually automated them to reduce risk and increase efficiency? Well, in this module, you will learn about the operational excellence pillar of the Azure Well-Architected Framework, which will enable you to answer these questions and improve the operations of your Azure cloud deployments. And as usual, even though the concept that we're going to discuss in this session, they're not all inclusive, but they definitely represent some of the important considerations when building a solution on the cloud. All right, so before we move on and actually talk about how a modern practice looks like and how you get there, I would like to show you this diagram. And maybe you actually recognize some part of it from your past experiences working in the IT industry. As you can see here, we are trying to illustrate a love and hate relationship between the development team and the operational team. Well, let's say the development team, they are actually very innovative and passionate with their work. They believe that the code that they produce will actually make big improvement in the production environment. And after months of code producing, they handed over the final results to the operational team. And when the package is opened, boom, as you can see illustrated here, nothing works and everything is broken. Well, we can definitely see that this is not benefiting the entire organization, and the end results can only be unhappy customers. So how can we resolve that? Well, over the years, I would say the development and the operational practices have really evolved to become more seamless and integrated. At least that's the goal that we're going to try to achieve. We have modern practices that involve organizational shifts and adopting new tooling in order to improve the operational agility of an organization. So in this small unit, you will learn some of the key concepts, how you can improve your organization's ability to build and deploy applications. And talking about modern operations, there's no way that we can avoid the concepts of DevOps, which is also one of the most popular buzzwords in the IT industry in the past years, I would say. So let's take this opportunity to explore a little bit more what DevOps is all about and what benefits you can get from it. Well, according to the formal definition, DevOps is the union of people, process, and products to enable continuous delivery of value to end users. DevOps really focuses on bringing the development team and the operations functions together and breaking down the existing barriers between them. This combination creates multidisciplinary teams that work together with shared and efficient practices and tools. Essential DevOps practices include, for example, agile planning, continuous integration, continuous delivery, and also monitoring of applications. With that said, the DevOps teams, they work in small batches and they focus on improving the end-to-end delivery of customer value, and they strive to eliminate waste and impediments along the way. And this is a very different approach compared to the siloed way of working that we saw illustrated in the previous slide. From a tooling perspective, there are several services and tools that are available from Microsoft to help an organization adopt and develop DevOps practices. Azure DevOps is the biggest of them, and it's a suite of products and tools that teams adopting DevOps practices can use to plan, to develop, deliver, as well as to operate their solutions. For example, as you can see in this diagram, it is a screenshot of the Azure board feature. This is part of the Azure DevOps that helps teams to plan and to track work. And the Azure boards has modern agile tooling integrated such as the Kanban boards, the backlogs, dashboards, and Scrum boards to enable the team to have greater visibility into the work that is planned and what has been delivered. And now let's take a look at another tooling. It's the very famous GitHub. GitHub, I would say, is the most widely used platform to build, deliver, and share software, and it is really a true friend of the developers. At its core, GitHub is a version control platform that enables a global community of individuals and teams to collaborate on software development projects. And these projects can be either kept private within the organization, or more commonly, I would say they are actually shared through public communities of software developers. GitHub also includes features to build and test deployments, track issues, and create custom workflows in your repositories. And another point to call out that Azure DevOps and GitHub, they integrate together in many aspects, and these services are often used together by organizations that are operating or adopting a DevOps model. For example, you can actually choose to use the pipeline feature in Azure DevOps, but you can still have your source code located in the GitHub repo. That is just one simple example. And whenever we talk about DevOps, there's also no way we can avoid the concept, the continuous integration and continuous delivery, because the CI/CD is really at the core of DevOps. And both CI and CD constitute two of the most important processes in any DevOps pipeline. If we take a look at the continuous integration first, this is the practice of building and testing code every time a team member commits changes to version control. So basically, CI encourages the developers to share their code and unit test by merging their changes into a shared version control repository after every small task is completed. And committing code triggers an automated build system to grab the latest code from the shared repository and then build, test, and validate the full master branch. The biggest benefit, one of the biggest benefits you can get out of the continuous integration process is to let the developers identify the bugs earlier, and it can therefore improve software quality since code is checked in, built, and verified more frequently now. Instead of working on code for months and discovering numerous issues when changes are eventually checked in, developers can check in smaller sets of changes and be confident that their code doesn't introduce large volumes of issues into the master branch. And now if we shift to the right and looking at continuous delivery, this is really about the ability to deploy your integrated code into production without the need of human intervention. CD allows you to take the code stored in the repository and continuously deliver it to production. And if you now look at them together, continuous integration and continuous delivery, they are often combined into a single pipeline known as CI/CD. A CI/CD pipeline is a path for delivering a unit of change that starts from development to delivery, usually consisting of four main phases, namely commit, build, automate test, and deploy. As a developer, you can check in code, validate that it passes all the tests and introduces no new issues into the master branch, and then roll it out to production with the confidence that it will not impact the operation of your production environment. So from a value proposition perspective, having a CI/CD pipeline really creates a fast and effective process of getting your product to the market before your competitor, as well as releasing new features and bug fixes to keep your current customers happy. Some of the benefits of implementing CI/CD pipelines to your everyday software development process include reducing cost, faster release rate, smaller code changes, increased team transparency and accountability, and last but not least, easy maintenance and updates. And back from the tooling perspective in the Microsoft ecosystem, in Azure DevOps, we have the feature called Azure Pipeline. It is basically a cloud service that you can use to automatically build and test your code project and make it available to the others. It works just about any language or project type and integrates with GitHub, GitHub Enterprise, Azure repos, and other version control systems. Azure Pipelines combines continuous integration CI and continuous delivery CD to constantly and consistently test and build your code and ship it to any target. GitHub Actions, probably you are also using or you have heard about it, can also be used to build a CI/CD pipeline in your GitHub repositories. With GitHub Actions, you can build workflows that are custom automated process to build, test, package, release, and deploy code. So that is another alternative that you can consider choosing. The last call out when we're talking about modern operations is the importance of having consistent environments. This is key to ensure that you can actually develop and deploy applications with confidence. As your CI/CD processes move your code through your environments, any variation can risk introducing areas where testing can fail or overlook defects. Through automation, you can spin up and tear down environment as needed, which can be included as part of your CI/CD processes. Imagine an environment where you were building a .NET Core application and your test and production environments were running different versions. Your deployment may succeed in your test environment, but causes issue later on in your production environment because it's running a completely different version of your application. That's why including your environment definitions as part of your deployment will help ensure that your code is built and deployed on a consistent end-to-end infrastructure. Now let's take a pause from all the DevOps discussion and move on to another area, which is monitoring and analytics. Let's say that you ran an operations team that was responsible for resources running on Azure. What would you actually do to ensure you had visibility into the health of your systems? So basically, if something happens, who finds out that first? Is it your team or your end users? I guess the answer is very straightforward. Well, monitoring is the act of collecting and analyzing data to determine the performance, health, and availability of your business applications and the resources on which they depend on. An effective monitoring strategy can help you to focus on the health of your application, and it can also help you to increase your uptime by proactively notifying you of critical issues so that you have the time to resolve them before they are actually noticeable by your end users. When it comes to monitoring and analytics on Azure, we can bundle the services into these three specific areas of focus: core monitoring, deep infrastructure monitoring, as well as deep application monitoring. In the next subunit, we will together take a look through each of these bundles, and we will learn how Azure services enable these capabilities for your architecture. I understand that even though we try to group these services together, there are several integration points between them, which allows you to share important monitoring data. And finally, the illustration on the right-hand side shows the available monitoring services assembled into logical groups. You might recognize some of the icons, and together we'll also see how some of these work in a small demo later on. All right, so first let's take a look at the first bundle, which is core monitoring. When we talk about fundamental monitoring, you can think about this as monitoring what is happening with your resources at the Azure platform level. And this area of focus gives you insights into things like the health of your Azure platform, changes being made to your resources, and the performance matrix. Azure provides services to give you visibility into 4 key core monitoring areas that you can see written in the boxes. These are activity logging, the health of cloud services, matrix and diagnostics, and last but not least, recommendations on best practices. These services are built into Azure and take little to no configuration to enable and set up. And now let's take a closer look at each of them. Activity logging is an incredibly important source of information about what is happening with your resources at the Azure platform level. Every change that is submitted to the Azure platform is tracked in the Azure activity log, which gives you the ability to trace any action that is taken on your resources. The activity log can contain information on activities that let you discover, for example, who has attached a disk to this virtual machine, when was this virtual machine shut down, who did the auto scale operation on my virtual machine scale set and it failed, and so on and so forth. Using activity log can answer this type of questions, and it will help you very efficiently in troubleshooting issues, tracking changes, and providing auditing of what's happening in your Azure environment. Azure Activity Log is only retained by default for 90 days, although you can archive your data to a storage account, or you can send your data to Log Analytics for longer retention and further analysis. The second box is the health of cloud services. At some point, any system can have issues, and that's true for Azure services as well. Staying informed of the health of Azure services will help you understand if when an issue that is impacting an Azure service is impacting your environment. What may seem like a localized issue could be actually the result of a more widespread issue globally, and Azure Service Health provides this insight to you. Then we have the third option, the matrix and diagnosis. For issues that are more localized in nature, it's important to have visibility into what is happening on your system or service instances. The ability to view matrix and diagnose information is very critical for troubleshooting performance issues and staying notified when something goes wrong. And to provide this visibility, Azure services have a common way of showing health, matrix, or diagnosis information. The tooling we're using here is called Azure Monitor. It basically enables that core monitoring for Azure services by allowing the collection, aggregation, and visualization of matrix, activity logs, and diagnosis logs. And in the very end, we have the recommendations on best practices. When we think of monitoring, we typically think of the current health of a resource, but even when the resource is healthy, there could be adjustments that would result in greater availability, reduce costs, or improve security. And again, we can use Azure Visor to help by keeping an eye out for potential performance, cost, high availability, or security issues within your resources. Advisor makes personalized recommendations based on resource configuration and telemetry on your environment and provides you with guidance that most traditional monitoring platforms cannot provide. While the monitoring components we have covered so far are great at offering insights, they only give visibility to the Azure platform. For typical IS workloads, there's more diagnosis information and metrics to gather from the network or the actual operating systems. For example, using log analytics, you can provide deep insights by pulling information from SQL Server to ensure that it's properly configured, analyzing free disk space across all the service environments, or visualizing the network dependencies between your systems and your services. That's why when you are designing a monitoring strategy, it's very important to include every component in the application chain so that you can correlate the events across services and resources. Services that support Azure Monitor can be easily configured to send their data to a log analytics workspace. And VMs, both in the cloud and on-prem, can have an agent installed to send data to log analytics. You can submit custom data to log analytics through the log analytics API. The following illustration shows how log analytics acts as a central hub for monitoring data. Log Analytics receives monitoring data from your Azure resources and makes that data available to consumers for analysis or visualization. With this data in Log Analytics, you can then query the raw data for troubleshooting. With this data in Log Analytics, you can query the raw data for troubleshooting, root cause identification, and auditing purposes. For several non-services, for example, like SQL Server and Windows Server Active Directory, there are readily available management solutions that visualize monitoring data and uncover compliance with best practices. Log Analytics also allow you to create queries and interact with other systems based on those queries. The most common example is an alert. Maybe you want to receive an email, for example, when the system runs out of disk space, or best practice on your SQL Server is no longer being followed. Log Analytics can send alerts, kick off automation, and even hook into custom APIs for things like integration with your existing IT service management system. And now we are arriving at the third bundle of services in the monitoring scope. It's important to understand how the core services and the infrastructure are performing, but you can take your monitoring capabilities even further by looking deep into your applications to identify performance issues, usage trends, and the overall availability of services you develop and depend on. By using an application performance management tool, you can better detect and diagnose issues that occur within your web apps and services. Azure Application Insights is the tool that we are looking for here. It basically allows you to do exactly the features that we talked about. Application Insights provides telemetry collection, query, and visualization capabilities. Instrumenting this level of monitoring requires little to no code changes, and you only have to install a small instrumentation package into your application. Application Insights is cross-platform, supporting .NET, Node.js, or Java. For instance, the response time for one of your applications might be complex to troubleshoot. For example, is the web server being overloaded? Is a specific SQL query not optimized? Is an API that you're calling performing slower than usual? Application performance monitoring solutions can help uncover the underlying issues that basic metric monitoring can't expose. The following screenshot shows a graphical display of an application's performance details provided by Azure Application Insights. Now you can find this module directly integrated with Azure Monitor as well. All right, now it's demo time again. Let's go to my demo environment and I will show you how Azure Monitor can be utilized to perform some of the major features we just went through. Now I'm again at my Azure portal and let me first navigate into Azure Monitor. Okay, so Azure Monitor is basically one of the platform tooling we have that delivers a comprehensive solution for collecting, analyzing, as well as acting on telemetry from both the cloud workloads as well as on-prem environments. And here are some top features what you can do with Azure Monitor, and I will try to demonstrate some of them today. So first thing I want to mention, there are essentially two main types of data that Azure Monitor is collecting. The first type is called matrix, and these are, as the name suggests, numerical values that are collected at a particular time interval. And these data are very good if you want to plot them in real time to see what is the utilization changes, how the trend has been like. And then we have the other one called the logs. And these are more comprehensive information that let you see not only just a number, but also other information, some attributes. And these are stored in a log analytics workspace for which you can then run queries on and then perform different type of analysis. So first, I will show you how the matrix looks like. To start with, I will need to decide on the scope. And let me try to use this subscription. And let me just try to find a VM with some data in it. Yeah, let me try this VM. After you have selected the scope, next you also need to choose what's the exact matrix that you want to visualize. And for simplicity, I will just use the percentage CPU. As you can see, this graph gives me the indication how the CPU utilization changes for this particular VM. And this time interval, as you can see here, is from the past 24 hours, but you can customize this from here. All right, so now I've seen my matrix and this diagram is looking a little bit suspicious. Something must be going on. And I would like to set an alert rule based on this matrix. When you create an alert rule, there are different information you need to provide. The first one is the scope, and I have already provided that the scope will be this VM. Then for the condition, since I started from this matrix, I just need to finish what is the actual threshold of the CPU percentage. As you can see here, there are two types of threshold that I can use. One is static, meaning that I will provide arbitrarily a value, and above that the threshold will be broken and the alert will be triggered. Another way is to use a dynamic threshold. And in this way, we are leveraging on built-in AI mechanism to identify from historical data what could be a reasonable threshold to put there. But for now, I will just use the static threshold. And I would say I would like to be alerted if the CPU utilization is above 70%. And this diagram gives me a hint based on the data from the past 6 hours at what time I will actually get an alert on. You can also choose the evaluation, how long is the aggregation granularity period, and what is the frequency of the evaluation. So with that, I have finished my condition setup. And lastly, I also need to give what will be the actual action when the alert is triggered. And here we are utilizing exactly the same concept that we talked about in the budget alert when we talk about cost optimization, which is to use the action group. You can utilize the action group to notify a particular stakeholder, and you can also do some concrete actions such as run an Azure function, call an Azure Logic app, or run a webhook connection, just some examples. But for now, I will just use the send email functionality by using one of the existing action group I have. Then in the very end, you just need to provide what is the name of the alert, description, and where you're going to apply the alert on, and the severity of the alert. After that, you're good to go. All right, and now let's go back to Azure Monitor. I can also show you how the logs experience looks like. This is the interface you'll be using when you are doing the query for the logs that are stored on this log analyst workspace. And here I have already prepared a simple sample query. The syntax that you are seeing here is using the Crucial Query language, KQL. It's quite similar to SQL, but this one has very good performance. It works extremely well when you try to coordinate different sources. And in this query, I'm just trying to find all the Windows machines that are giving me back the heartbeat signal. And as you can see, almost instantly, I'm getting back the results. I have 82 items being returned for this particular subscription when I try to run this query. Another very important aspect in all monitoring tool, I would say, is visualization. And in Azure Monitor, the dashboard, at least one of the types of dashboard you can utilize is called a workbook. And the workbooks, they are extremely dynamic dashboards that will update almost instantly if there's any change. Because essentially behind all the different diagrams, it's supported by a KQL query that retrieves the data from your log analytics workspace. So if I use one of the built-in workbook, I can show you, let's try the key matrix. So this workbook shows me how are my VMs doing in the particular subscription. And in this case, I can first get the overview of what is my CPU utilization for all these different machines. I can also see some key matrix. Yeah, so here you can see these are displayed by the order of percentage CPU utilization, and you get to see some other useful statistics about them. You can also see where your VMs are located and whether they are healthy or not. The last thing I'm going to demonstrate are the different insights solution. So basically the insights, these are pre-built monitoring solution depending on whether you have a particular type of resource. So today we have already built insights solution for VMs, storage accounts, containers, network, just to name a few. And again, let me utilize the VM example. From the overall page, you can see, again, select the scope that you want to visualize and see whether those VMs have already been onboarded using VM Insights or not. Let's take this VM as an example. So what you can see from here, the first view is this map view where you get to explore more in details what are the different processes that you are already running on your VM. And in terms, which are the other servers that a connectivity has been established and which ports they're using. And the prerequisite for you to get this map view is to install the dependency agent. It is another agent that needs to be installed together with the log analytics agent if you want to get this level of the details. In addition, you can also view the different performance graphs based on this particular VM. For example, the logical disk performance, CPU utilization, available memory, and so on and so forth. All right, so that is a very quick demo about Azure Monitor. And now we'll go back to the slides to continue on the other topics. All right, so now let's go back to the slides and we'll continue explore what are the activities you can do to enhance your operational excellence. Now in this new area, we're going to talk about how you can utilize automation to reduce effort and error. Managing the infrastructure for any type of workload involves configuration tasks. And this configuration can be done manually, but we all know that manual steps, they do not scale very well. In addition, they can be labor intensive, they can be prone to error, and very inefficient. What if you are assigned to lead a project that requires the development of hundreds of systems on Azure? How would you build and configure these resources and how long time would this take? Could you ensure that each system was configured properly with no variance between them? Well, the ultimate answer for these questions would be to use automation. By using automation in your architecture design, you can work past these challenges. In the next couple of slides, you will learn about some of the ways how you can achieve automation on Azure. The first topic I'm going to bring up is infrastructure as code, also known as IAC. This is basically the management of infrastructure, such as your networking elements, your VMs, your load balancers, as well as how these different elements are connected together, that topology. And with IAC, you will do it in a descriptive way using a versioning system that is similar to exactly what the developers today are using to store source code. When you are creating an application, the same source code will generate the same binary every time it is compiled. And in a similar fashion, an IAC model generates the same environment every time it is applied. That's why IAC is another very key DevOps practice, and it is often used in conjunction with continuous delivery as well. IAC basically evolved to solve the problem of environment drift. Without infrastructure as code, teams, they have to maintain the settings of individual deployment environments. And over time, each environment can really become a snowflake that is increasingly unique and cannot be reproduced automatically. The administration and infrastructure maintenance of these snowflake environments involves manual processes that are hard to track and contribute to errors. And the resulting inconsistency between these snowflakes environments lead to issues during deployment. So to summarize a bit, we can say the biggest benefits brought by IAC, including to keep a single source of truth, meaning that the configuration of the infrastructure will only be stored as code format in your common repo. And with that, you can have increased repeatability and testability. The direct outcome is decreased provisioning time, as you can literally at any time tear down your environment and build it from scratch. And you have the confidence that it will always look the same without any drift. When automating the deployment of services and infrastructure, there are two different approaches that you can take, and these are the imperative and declarative approaches. With an imperative approach, you explicitly state the commands that are executed to produce the outcome. And with a declarative approach, on the other hand, you specify what you want the outcome to be rather than how you're going to do it. I would say both approaches are valuable and there's nothing wrong which ones you go for. If you explore them a little bit more in details, in imperative automation, we specify how things are to be done. And this is typically done programmatically through a scripting language or SDK. For Azure resources, we could use the Azure CLI or Azure PowerShell. And let's take a look at an example that uses the Azure CLI to create a storage account. In this example, we'll specify how to create these resources. Execute a command to first create a resource group, then execute another command to create a storage account. And we are explicitly telling Azure which commands to run in order to produce the output we need. So with this approach, we are able to fully automate our infrastructure. By automating the resources, we've taken the manual steps out of the process and making resource administration optionally more efficient. However, there are also some downsides to this approach. For example, scripts to create resources, they can quickly become very complex as the architecture becomes more complex. And error handling and input validation may need to be added to ensure full execution. Last but not least, the commands may change over time as well. That's why you need to have extra effort to do maintenance of the scripts. With declarative automation, on the other hand, we are specifying what we want our result to be and leaving the details of how it's done to the system we are using. On Azure, declarative automation is done through the use of Azure Resource Manager, the ARM templates, which are JSON structured files that specify what we want to be created. ARM templates have four main sections: parameters, variable, resources, and outputs. If you look at the snippet below, this is from the ARM template that you can use to create a storage account with the names and properties that we specify. The actual steps that are executed behind the scenes to create a storage account are left for Azure to decide, and we only need to provide the desired state. Another generic language to do IAC cross platforms is to use Terraform. And if you look at the trade-offs, the benefits, and the disadvantages, you can use ARM templates to create and manipulate most resources on Azure. And you can store your templates in code repos and inherit all the benefits of using a single source control system. And you can also share your template across environments to ensure that the infrastructure you use for your development environment matches, for example, your production environment. And the templates are a great way to automate deployments, and they help ensure consistency, eliminate deployment misconfigurations, and can increase operational speed. One downside is probably that the syntax can get a bit lengthy, and when you have a complicated system, the templates can get also rather hard to keep maintaining. All right, so we looked at how you can use IAC to automate your infrastructure deployment, and that's a fantastic first step. But when you are deploying your VMs, there's actually still more work to be done. Let's take a look at a couple of approaches that you can utilize to automate the configuration post-deployment. As mentioned, for many VM deployments, your job isn't quite finished yet when the VM is simply up and running. In many situations, you also need to do some extra configuration and install some other software. For example, some additional disk might need formatting, the VM might need to be joined to a domain, and an Azure file management software package might need to be installed. And most likely, the actual workload requires installation and configuration as well. There are, again, two common approaches that you can use for the configuration work, which for all intents and purposes are considered to be part of the configuration process for the VM itself. And each of these strategies has its advantages and disadvantages. The first approach is to use custom images. Custom images are generated by deploying a virtual machine and then configuring or installing software on that running instance. When everything is configured correctly, the VM can be shut down and an image is created from the VM. This image can then be used as a base for deploying other new VMs. Working with custom images can speed up the overall time of your deployment because as soon as the VM is deployed and running, no additional configuration will be needed. If deployment speed is an important factor, custom images are definitely worth exploring. Post-deployment scripting, the other approach, typically leverages a basic base image and then relies on scripting or configuration management platform to perform the necessary configuration after the VM is deployed. The post-deployment scripting could be done by executing a script on the VM through the Azure script extension or by leveraging a more robust solution such as the Azure Automation Design State Configuration, also known as DSC. After we have looked at what each approach is about, I would like to share some considerations to keep in mind when you are choosing between them. When using images, you need to ensure that there's a process to handle the image updates, security patches, and inventory management of the images themselves. With post-deployment scripting, on the other hand, build types can be extended since the VM can't be added to live workloads until the build is complete. And this may not be a significant issue for standalone system, but when using services that auto-scale, such as virtual machine scale sets, this extended build time can impact how quickly you can scale. With both approaches, you want to ensure that you address configuration drift. As new configuration is rolled out, you need to ensure that existing systems are updated accordingly as well. Automating resource deployment can be a massive benefit to your environment. The amount of time saved and the amount of errors that are reduced can move your operational capabilities to another brand new level. Once your solutions are up and running, there are ongoing operational activities that can also be automated. Automating these tasks with Azure Automation reduces manual workloads, enables configuration and update management of compute resources, and provides a framework for running any type of Azure task, and centralizes shared resources such as schedules, credentials, and certificates. If you look at some examples, this could include periodically searching for alternate disks, installing the latest security patches on VMs, searching for and shutting down VMs in off hours, or running daily reports and producing a dashboard to report to senior management. We have already looked at some of the ways, such as the script to search for alternate disks in the cost optimization episode of this series. And here you have a quick review again. As an example, let's suppose that you want to reduce your compute costs by configuring one of your development virtual machine to run only during your organization's business hours. You can write a script to start the VM in the morning and shut it down in the evening. And you can also configure Azure Automation to run the script at set times. The following illustration shows the role of Azure Automation in this process. Finally, at the end of your cloud infrastructure pipeline are a collection of development machines, which are used by your developers to write the applications and services that are core of your business. You can use Azure DevTest Labs, for example, to deploy VMs with all the correct tools and repositories that your developers need. Developers working on multiple services can switch between development environments without having to provision a new VM themselves. And these development environments can be shut down when they are not in use and then restarted when they are required again. And it's a good option to again do cost optimization. All right, so now we have finally come to the very last topic that we're going to cover in the session, how you can improve your operational excellence. We're going to talk about how you can leverage on different testing strategies for your application to achieve that. First, I would like to mention that testing is absolutely not a new concept. Even in the old waterfall model, testing has already been established as one of the important phases before you move your product to production. And now in the new model, it is only getting more and more important. I would say testing is one of the fundamental components, again, of DevOps and Agile development in general. If automation gives DevOps the required speed and agility to deploy software quickly, only through extensive testing will those deployments achieve the required reliability that customers demand. In addition, a main tenet of DevOps practice to achieve system reliability is the shift left principle. If your process for development and deploying an application is depicted as a series of steps that are listed from left to right, your testing should be shifted as much as possible toward the beginning of your process, which means that you should always start testing as early as possible and not just at the very end of your process in the waterfall model. Errors are far cheaper to repair when they are caught early, and issues can be expensive or impossible to fix later in your application lifecycle. Testing should also occur on both application code and infrastructure code, and they should both be subject to the same quality controls. The environment where applications are running should be version controlled and deployed through the same mechanism as application code. As a result, both application code and infrastructure code can be tested and validated using DevOps testing paradigms. You can use your favorite testing tool to run your tests, including Azure Pipelines for automated testing and Azure Testing Plans for manual testing. Last one to call out, there are multiple stages at which tests can be performed in the lifecycle of code, and each type of testing has several considerations that are important for you to understand. And in the next two slides, we will look at what are the different testing strategies that you can find, and we will group them into automated and manual test categories. To start with, let's take a look at the automated testing. Automating tests is the best way to make sure that they are executed. Here I'm showing you a couple of test types that are great candidates to automate them. The first one is unit testing. Unit tests are tests typically run by each new version of the code that is committed into your version control system. And unit tests, they should be extensive, aiming to cover 100% of the code, and quick, typically under 30 seconds, although this number is not a rule set in stone. Unit testing could verify things like the syntax correctness of your application code, resource manager templates, or Terraform configurations, that the code is following best practices, or that it produces the expected results when provided certain inputs. Then continue on, we have the smoke testing. Smoke tests are more exhaustive than unit tests, but still not as much as integration tests. Smoke tests normally run in less than 15 minutes, while smoke tests do not verify the interoperability of your different components with each other. They verify that each component can be correctly built and each component meets your criteria for expected functionality and performance. Lastly, smoke tests usually involve building the application code, and if you are deploying infrastructure as part of your process, then possibly testing the deployment in a test environment. And lastly, we have the integration testing. After making sure that your different application components operate correctly individually, Integration testing determines whether your components can interact with each other as they should be. Integration tests usually take longer time than smoke testing, and as a consequence, they are sometimes executed less frequently. Giving an example, running integration tests every night still offers a good compromise between the different types of automated testing. And now let's switch to the other side and look at what you can do with manual testing. Well, manual testing is much more expensive than automated testing, and as a consequence, it is used less frequently than automated testing. However, manual testing is fundamental for the correct functioning of the DevOps feedback loop, and manual testing is used to correct errors before they become too expensive to repair or before they cause customer dissatisfaction. So you can't say that manual testing can be replaced 100% by automated testing. So some of the typical areas where you need to use manual testing. First, we have the acceptance testing. And there are different ways of confirming that the application is doing what it should. Maybe you have heard about blue-green deployments. And that means that when deploying a new application version, you can deploy it in parallel to the existing one. This way, you can start redirecting your clients to the new version. If everything goes well, you will decommission the old version. But if there's any problem with the new deployment, you can always redirect your clients back to the older deployment, and therefore it's called a blue-green deployment. Another common approach is the canary release. You can expose new functionality of your application to a select group of users, ideally using what we call the feature flags. If these users are satisfied with the new functionality, then you can extend it to the rest of your user community. In this scenario, we're talking about releasing functionality and not necessarily about deploying a new version of the application. Just also want to mention that an important aspect to consider in acceptance tests is how to measure the effectiveness of new features in an application. One way to do that is through the application insights user behavior analytic, which you can use to determine how people are using your application. By analyzing the results, you can decide whether a new feature has increased or decreased your application's usability. Certain services in Azure offer functionality that can help you implement this kind of test. For example, the deployment slot functionality in the Azure App Service allows you to have two different versions of the same application running at the same time, and you can redirect your users to one version or the other. Then we move on to talk about the second box, the stress test. As other sections of this framework have explained, designing your application code and infrastructure for scalability is of paramount importance. With this in mind, it is critical that you test whether application and infrastructure code will both be able to adapt to changing load conditions. For example, if there is a spike in user activity, you need to be confident that your application and infrastructure will scale automatically to meet the increased demand. And that's the reason we have stress tests. It is critical that you monitor all the different components of the system in order to identify whether there are any scale limitations. Every component of the system that is not able to scale out can turn into a bottleneck, and it is important for you to know the limits for each of your components so you can mitigate their impact into your application scale. As you learn more about the performance characteristics for each of your components, the discoveries that you make along the way might motivate you to replace some of your components with more scalable counterparts. Then moving on to the third one, fault injection. Your application should be resilient to infrastructure failures, and introducing faults in the underlying infrastructure and observing how your application behaves is fundamental for increasing the trust in your redundancy mechanism. For example, ungracefully shutting down infrastructure components, degrading the performance of certain elements such as network equipment, or purposely introducing faults in the environment are different ways of verifying that your application is going to continue to behave or react as expected. And lastly, we have the security test. Another critical component of your test strategy should be routine testing of your application for security vulnerabilities. You should regularly perform security tests against your application to identify any application vulnerabilities that are introduced through code defects or through software dependencies. And these tests can include automated security scans to test against common vulnerabilities such as cross-site scripting or SQL injection. Your security tests can also include red team exercises where the security teams attempt to compromise your application. Use the results from this test to provide feedback through your entire development process and resolve any security issues that you find in your code or software dependencies. All right, so now we are again at the end of this session, and here is the summary page of what we discussed today. What are the different activities you can do to improve your operational excellence of your environment or your customer's environment? We started by discussing how you can build a modern practice around your operation. And there we talked about why it is so important to embrace the culture of DevOps, how you can utilize CICD pipelines to streamline the process, and why it is so important to have consistent environments to make sure that you set the foundation for success. Then we move on talking about how you can always knowing and do an efficient monitoring of your workloads on the different levels. You can use core monitoring to look at how your Azure platform level is doing. And then we also have deeper monitoring capabilities for both infrastructure as well as application. In the third box, we look at the different mechanism, what you can automate on your platform. For the infrastructure, you can utilize infrastructure as code to save the setup in a single source of truth in a code repository. And you can also do automation of both post-deployment configuration as well as the other operational tasks that the user need to perform. And finally, we also highlight the importance of testing, and we look at different testing types that you can utilize in both automated setup and a manual setup. As usual, I prepare some additional resources that you can look into. So mainly here, I selected different learning paths that you will find on the Microsoft Learn platform to know more about DevOps, how to use Azure Monitor, how you can do infrastructure as code using ARM templates, and some other content about automation. Right, and in the final slide, the Q&A corner, I have again prepared 3 questions that I think might be useful to you. The first question is, if I don't have any previous experience, how do I start with DevOps? Well, it's a little bit broad question, but I would say you still need to follow a systematic approach to learn DevOps. And this requires enterprises to craft a step-by-step transition to DevOps and not just throw out everything old and bring everything new at once. First of all, you need to define what are the steps that you're going to achieve. First, by maybe creating a transformation roadmap, and then the next step, selecting what are the different tool chains you want to use. And also important to set your automation goals, and these goals must be realistic, as the chance to fail is higher if you set very ambitious goals to just say automate everything at once. And in addition, we also have many good trainings to get you prepared. For example, one of the certifications Microsoft offers is the AZ400 Azure DevOps Expert, and we have many great training resources for that. And last but not least, it's also good to start running a pilot project to see what are the areas that you can stumble upon and learn from that experiences. Okay, and another question, from a partner perspective, how can I set up a monitoring strategy for my customers at scale? To answer this question, I need to introduce another product we have, which is Azure Lighthouse. That is the tool that helps the partner to solve the scaling issue so that they can basically replicate the same strategy that they have for one customer across multiple customers. And monitoring strategy is just one of them. So as you saw in the demo, Azure Monitor, that tool is already very much integrated with Azure Lighthouse. So many features such as the workbooks, such as VM monitoring, querying logs from the log analytics workspace. With the support of Lighthouse, you can easily use the same user interface, but apply them to many customers at once at scale. If you want to know more detail, you can listen to my webinar about Azure Lighthouse. And the very last question, can you give any concrete tips how to start transforming to IOC if today everything's still done on a manual setup? For this question, I will highlight that there are actually many practical resources that you can utilize without having to write all the different templates, the scripts from scratch. For example, actually the last link that you can find in the resource list, that is a GitHub repo where you can find many different, I think we have already hundreds of different ARM templates to provision resources of various types. So you can always start from there and look for if there's any matching template that suits your business requirements. And you can also actually take that as a baseline and do modifications if needed. And another tip is to check out the Azure landing zone part in the cloud adoption framework. For the enterprise scale, this is an architecture approach and a reference implementation that enables effective construction and operationalization of landing zones on Azure. We have already provisioned some existing infrastructure as code playground that you can start building your own version on. So again, there's no need to start from scratch and do everything by yourself. Okay, so with that said, again, thank you so much for joining me in this webinar. We have already gone through 2 out of the 5 pillars, only 3 more to go. Next time, we're going to look at how you can improve performance efficiency of your environment or your customer's environment according to the Microsoft Well-Architected framework. Stay tuned and see you next time.